Hello everyone, my name is Dennis and I welcome you to this course of electrostatics. In this lesson, I'm going to go through the course outline that we'll be following throughout the course. So we'll have our course outline for this course. Let me have more space. Okay, so this is how we are going to run the course. We have our course of electrostatics. So the first part that we are going to be looking at is going to be about the types of materials as we classify them in terms of electrostatic behavior. So we'll begin by looking at the types of materials. This is going to be our first topic in this course. We'll go ahead and look at the term charge. This is very important because electrostatics is mainly about the study of charge. So we'll look at charge, we'll look at what charge is, we'll define the term charge. We'll go ahead and look at the properties of charge. We will also look at the types of charge, and we'll look at the experimental verification. We'll look at the experimental verification of the two types of charges that we'll look at. Our third chapter in electrostatics is going to be about a very important phenomenon called electrostatic charging. Electrostatic charging, and under here we are going to look at the methods used to charge things in electrostatics. Here we'll look at how to charge things by induction or electrostatic induction. We'll look at how to charge by friction or by rubbing. We'll go ahead and see how to charge things by contact or by conduction. Conduction. Okay, this is going to be our third subtopic. Subtopic number 4, we are going to look at the gold leaf electroscope. The gold leaf electroscope. This is a very important device that we use in many experiments, and we are going to be looking at its use frequently throughout this topic. So we'll dedicate some time to look at the gold leaf electroscope. The gold leaf electroscope, we'll look at how it works. We'll look at how it works and what are its uses. Okay, we'll try to also look at Coulomb's law, which is basically a quantitative analysis of charges. So under Coulomb's law, we'll look at the force between charges, basically how to calculate it. Okay, and this is going to be the first part of the course of electrostatics. We'll begin by looking at the types of materials. We'll look at conductors, insulators, semiconductors, and superconductors. We'll go ahead and look at the types of charge, their properties, and how to experiment this. Our third subtopic, we are going to look at electrostatic charging. Number 4, we are going to look at the gold leaf electroscope, which is a very important device in electrostatics. And we'll conclude this first part by looking at Coulomb's law, which is a quantitative analysis of the force between electrostatic charges. And from here, we'll move on to the second video where we'll be talking about electric fields. So thank you for watching. Next, we now start to look at the types of materials. Before we look at the types of materials, let us first understand the word electrostatics. The word electrostatics comes from two words, or we can break it down into two parts: electro and statics. These two words give us a broad sense of what we are going to be covering in this course. Electro is a short for electricity or electric charge. I'll call this electric charge, and you know very well from mechanics, which is a branch of physics, we know very well that statics means the study of particles at rest, or objects. I think that's better. The study of objects at rest. So in electrostatics, we combine the electric charge behavior with the study of objects at rest to bring together what we call electrostatics. Essentially, electrostatics is a branch of physics, that deals with the behavior By behavior, we mean the characteristics, the behavior of charges at rest. The behavior of charges at rest. Charges have very interesting properties when they are at rest than when they are in motion. When charges are in motion, they constitute an electric current, which is not the case here when the charges are at rest. So in this course, we will not concern ourselves with electric current, so we will not study what happens when charges are in motion. We will study what happens when charges are at rest. That's electrostatics, the study of, or the branch of physics that deals with the behavior of charges that are at rest. Let's go back to our course outline. What did we say? We begin with the types of materials. That's going to be our first lesson. Types of materials. Now, with reference to electrostatic behavior, materials are broadly categorized into two types. That is to say, we have conductors and we have insulators. However, there are some materials that we cannot call totally conductors or totally insulators. They somehow lie between the two groups, conductors and insulators, so they form the third category, and we call them semiconductors. Also, there are some materials that are conductors, but their degree or level of conductivity is too high to be compared with normal conductors, so they also take a separate part, and we call them superconductors. We'll be looking at these in a while. Superconductors. Okay, to understand the difference between all these four types of materials, but to be specific, to understand the difference between conductors and insulators, we'll have to look at the atomic view of these materials. So the modern picture of an atom is as follows. So the modern picture, oops, this is looking not good. Okay, the modern picture of an atom is as follows. In the modern picture of an atom, to begin with, we have a nucleus which is having positive charges, protons in it, and the nucleus is surrounded by a cloud of electrons around it, an electron cloud like that. So this is the nucleus, and these are energy levels surrounding the nucleus in which we find electrons. These electrons combined together form an electric cloud. Now, in a neutral atom, of course, the number of electrons, which are the negative charges, must be equal to the number of protons, and in that case we say the atom is neutral. We'll look at this later. Neutral means the state in which the net charge on an object is zero. It does not necessarily mean absence of charge, but it means the total charge, the total net charge is zero. Okay, let's use this to understand the difference between conductors and insulators. Well, In both materials, conductors and insulators, the atoms look the same. They have a positive nucleus and an electron cloud around them. However, the main difference between conductors and insulators is the force with which these electrons are bound to the atom. You see, in conductors, the forces on the outermost electrons, of the atom are somehow weak. So the forces are weak. That means some of these electrons can escape from the atom. So you have an atom, but the forces that are keeping these electrons around the nucleus, when they become weak, especially if you supply some heat energy or some other physical condition, these electrons can gain some energy and perhaps one of them could escape. So in a typical conducting material, in a typical conductor, we have some fraction of the electrons that are not bound to the atom, and so these unbound electrons are free to travel throughout the material, and because they are able to travel throughout the material, that makes the material to conduct. So ideally, when we say conductor, we mean a material that allows the movement, sometimes we can say transfer, of charge through it. The movement or transfer of charge through it. We have just seen why conductors allow the movement, because some of their electrons are not bound. So some of these electrons can escape. In other words, they can become unbound. So they are free to move within the material. Let me give you a picture of how this looks like. Consider this to be our conducting material. Inside our conducting material, we have many atoms. These atoms are packed together. As a matter of fact, on average, the interatomic distance is about 10 to power negative 10 meters. This is a very small distance between the atoms, closely packed. But inside, so this is a conducting material. Inside this material, there are some electrons that are free and they are not bound to the atoms. These are the atoms. So some electrons are not bound to the atoms, so they are free to move. These are free, unbound electrons. They are free to move in any part of the conductor, of all of the material, so they give it the ability to become a conductor because they can move through it. They enable charge to be transferred throughout the material. This constitutes what we call a conductor. Some common examples, we get another color of conductors. Common examples of conductors include most metals. In fact, all metals conduct. We also have some materials like salty water, and believe it or not, the human body is also a conductor, and also ionic chemical solutions also conduct electricity, because ionic means the presence of ions, positive and negative ions. Those ions make the solution to be a conductor. Okay, let's have a quick recap of what conductors are before we move to the next part. So in our picture of an atom, we said all materials are made up of this basic atom. Inside the atom, there is a positive nucleus surrounded by a cloud of electrons. The classification of the material as a conductor or insulator depends on the nature of this atom here. Some atoms have weak forces that are binding these electrons to the atom. So because of those weak forces, the electron, especially the outermost electrons, can easily escape from the atom and become free within the material. Like we see here, these electrons are free to move throughout the material, and when they become free to move throughout the material, it means the material is able to transfer charges through it, and by the way, also transfer heat, but we are not concerned about the transfer of heat in this topic. Okay, so in conductors, the forces on the outermost electrons are weak, and some of these electrons escape from the atom and they become free or unbound. So a conductor is a material that allows the movement of charge through it, since it has free electrons that can move throughout. And here we have an enlarged view of what looks like inside the conductor of a material. Typically, not each of these atoms will donate an electron. About 1 in 10th of these atoms will have free electrons escaped from them, and those electrons will contribute to the conductivity of the material. Let us now look at the next type of materials, and that is the insulators. Having understood conductors, it is very easy to understand what insulators are. And these are basically materials in which, okay, I should say materials which do not permit, or materials which do not allow transfer or the movement of charge through them. Some of the characteristics of insulators is that all the electrons are tightly bound. All the electrons are tightly bound to individual atoms. So you don't have any free electrons that can move throughout the material to contribute to its conductivity. And that's all we have to say about insulators. Maybe some examples of insulators. We have a couple of them here. All plastics are insulators. Wood is an insulator. Rubber is a good example of an insulator, and many other things. And by the way, each of these materials has its advantages for practical usage. For example, these materials are used to insulate electric cables. These materials are also used to handle hot objects, since they do not also conduct heat, and many other uses, whereas the conductors are used also in real life to make electric cables, and most kitchenware is made from conductors. Kitchenware mainly saucepans and some dishes. Okay, these are the two main types of materials in classification according to their electrostatic behavior. However, we looked at some in our introduction. We looked at some two special types of materials, that is the semiconductors and the superconductors. We will not go into their deep details, but we'll talk about them briefly. So let's begin with semiconductors. Semiconductors. So semiconductors are materials whose properties lie between those of conductors and insulators. What this means basically is that semiconductors have properties of both conductors and insulators, so they can conduct at some conditions and they can become insulators at some conditions. The main condition here is temperature. When the temperature is low, these materials are basically insulators. When the temperature is high, most of them become conductors. Okay, let's look at some common examples of semiconductors. Mostly, if you look at group 4 elements in the periodic table, like silicon, tin, germanium, selenium, and others are some examples of semiconductors. Well, the atomic theory behind conduction or the atomic theory behind the properties of semiconductors will not be discussed in this topic, but just to have a simple clue of how semiconductors work, semiconductors have two types of charge carriers. They have what we call the electrons, which are the negative charges, as we have seen, but they also have the holes, which are the positive charge carriers, as we shall see. I will make a separate video and leave a link in the description or a YouTube card to show you how these work. Mainly we'll look at them under current electricity. They have very interesting properties. They have two charge carriers, electrons and holes, so this gives them priority for use in the electronics industry because their conductivity can be modified by mixing them with other elements to increase their conductivity or to reduce it. Lastly, we'll look at superconductors. So superconductors, as the name suggests, are materials with very high degree or extent of conduction, and this is basically because they have very low resistance. Now, at least as of this recording, we do not have materials that are naturally occurring semiconductors, but some special materials at very low temperatures, can have very low resistance, and so we can consider them to be superconductors. So superconductors is a new type of material in the research industry, and it's already in use, especially in the field of electromagnetism, in making magnetic levitation trains. We need materials which can become magnetized to a very high extent of carrying a big mass. So this is how a picture looks like. We have an electric train, and the electric train is moving on rails. These rails have to be made of a superconductor. Because of this superconduction, you have very high current going through the rails. That means you have a great magnetic force. A great magnetic force that can lift the train up. Okay, Also, in this topic, we are not so much concerned about the magnetic properties of superconductors, but that's the field in which they are commonly used, and we'll continue to explore it in other videos about electromagnetism. That's it for this video about the types of materials. In the next video, we'll look at electrostatic charge, how to define it, its types, and the units for measuring electrostatic charge. Thank you.